Students, this is we have started a lecture series. This is lecture number 4 in the trigonometric of SSC mathematics. In this lecture 4 we are going to solve one example problem and one from the exercise 11.1 in the trigonometric chapter. First we will solve the example problem. Example we are going to solve. Okay, I will write first the problem what they have asked. They have given, consider a triangle PQR, right angled at R, in which they have given the lengths PQ is equal to 29 units. They have given units are centimeters, millimeters, you can take, and QR it is given 21 units, it can be centimeters, and they have given that angle PQR is equal to theta. Then they are asking, then find the values of, they've asked to here cos square theta plus sin square theta. Another problem of this question is cos square theta minus sin square theta. So we get a special case in this when we solve it, then you can understand. Okay, so we have to find cos theta and sin theta, and what they have given the problem, the right angle is at angle R, that is 90 degrees, and they have given the PQ and QR lengths. And first we will draw the right angle triangle, and they have mentioned the problem that the right angle is at R 90 degrees, and we can take now PQR. Now PQ is going to be the hypotenuse. They have given it as 29 units. You can take units or you can just write 29 also, because when we go for ratios the units will get cancelled. And they have given QR also, that is 21 units. QR is 21 units it is given. And they have given angle PQR. PQR is theta. This is angle theta which they have mentioned. This you can take, here they have not asked, it can be theta 1, but they didn't ask according for this angle. What they have asked is angle theta is at angle Q. I'll write here angle PQR, they are saying to consider it as theta. Okay, the central alphabet of this PQR is the angle which they have mentioned, that is theta, you have to take. Now we have to find cos theta and sin theta to evaluate this cos square theta plus sin square theta and cos square theta minus sin square theta. Okay, so we know that sin theta is the ratio of opposite side length divided by the length of the hypotenuse. Opposite to theta here is nothing but PR. So we have to find PR which is not given. So that is length of PR is L divided by the hypotenuse length, that is 29 units. L is also you can consider as units. So we can L units divided by 29 units. Units will get cancelled. It can be centimeters, it can be millimeters, it will get cancelled. So to calculate sin theta we need to have the length L, that is length of PR, we have to calculate. So how to calculate the length of PR? Can anybody guess? We have already seen the previous lecture that we have to use a theorem called, what it is? Pythagoras theorem we have to use. Pythagoras theorem is used here to find the length of PR. So we are going to write using Pythagoras theorem, which states that again PQ square, that is length square of the length of the hypotenuse, is equal to square of the length of adjacent side plus square of the length of opposite side. So here opposite to theta is PR, so and the adjacent side here is QR. So the length PQ is length of the hypotenuse, PR is the length of the opposite side to the angle theta, QR is the length of the adjacent side to the angle theta, right. So what they have given, PQ is given 29 square, you leave about the units, and we have PR square, it is given, we have taken it as L square, and QR it is 21 square. Okay, now what we have to find is L square, we need to find 29 square, it is nothing but 841. Okay, 29 square is 841 is equal to L square plus 21 square is 441. Now same way as we have done in lecture 3 earlier, we are going to bring this 441 on the left hand side. So we get 841 minus 441, that is equal to L square. Now what is L square is equal to 841 minus 441, it is equal to 400. From this we get L is equal to root 400, we have root 400, it is nothing but 20 units. You can write it as 20 units. Here we get, right. So we got the length of the opposite side to the angle theta. Now what we have to find is sin theta and cos theta, and we already have the hypotenuse length, that is 29, and we have the definition of sin theta, length of the opposite side to angle theta is 20 units divided by the length of the hypotenuse, that is 29 units. Numerator denominator will get cancelled. So this is sin theta, and we know that cos theta is nothing but, in the denominator you remember always for sin theta and cos theta denominator is same, that is hypotenuse, and numerator of cos theta is nothing but adjacent to angle theta, here we have it is nothing but QR. QR is the adjacent side to the angle theta, that is 21. So here cos theta is nothing but 21 by 29, and they ask the first question here is cos square theta plus sin square theta, they are asking to find. So what we do here, 20 by 29 square plus 21 divided by 29 square, this is what we get, and we can take the LCM here. LCM we get it as 841, which is nothing but 29 square. So we get LCM is 29 square, because in the both the terms we have denominator is 29 square. Now for the first term we have in the denominator is 29 square, 29 square will get cancelled, and we get it as 1 into 20 square. Same way for the second term also, 29 square in the denominator of this, and this will get cancelled, and we get 1 into 21 square. So we know that 20 square is nothing but 400 plus 21 square is 441 divided by 29 square is nothing but 841. So numerator is 841, 400 plus 441 divided by 841, both will get cancelled, and we get the ratio as 1. So what here we can conclude is, always for any angle theta, sin square theta plus cos square theta is going to be 1. This is very important identity which can be used in solving the problems. Sin square theta plus cos square theta is equal to 1. The second question asked in the problem is, they are asking to find what is cos square theta minus sin square theta. We know the ratios already. You need to just substitute and simplify the things. Cos theta we have already 21 by 29 square minus sin theta is 20 by 29 square. As usual, it is LCM is how much? 29 square. And here we get 21 square minus 20 square. Okay, so 21 square is nothing but 441. 20 square is 400 divided by 29 square is 841. So we get it as 441 minus 400, that is 41 by 841. So this is the answer we get for cos square theta minus sin square theta. Right. We'll solve another problem, that is from exercise 11.1. We'll solve problem number 1 in this. That is, they have given a right angle triangle ABC. ABC is a right angle triangle, and they have given the lengths of all the sides, and they are asking to find the sin A, cos A, tan A. Okay, they have given all the three side lengths. Okay, so you can take it as A, B, C. Okay, they have mentioned it as a right angle triangle, and they have given the diagram here. The right angle is at angle B, 90 degrees, and they have given all the lengths. AC it is given 17 centimeters, and here BC it is given 15 centimeters, and AB it is given as 8 centimeters. This is given. Okay, these are given lengths. What they are asking simply is to find sin A. Sin A is what? We take the angle here. This is sin A. Sin A is defined as length of the opposite side divided by hypotenuse, that is 15 centimeters divided by 17 centimeters. Centimeters will get cancelled and we get it as 15 by 17. And we can calculate cos A. Cos A is what? Can anybody tell now? Cos A. Cos A is length of the adjacent side, that is AB, and divided by the hypotenuse. Okay, length of the adjacent side length is nothing but AB, that is AB divided by AC, that is cos A. AB is 8 centimeters and AC is 17. Always remember, length of the hypotenuse is going to be longer, it is going to be longer than other two sides. And if you want to find tan A, you can take the ratio of sin A divided by cos A, or you can take it as opposite by adjacent side lengths. Opposite side to A is 15 divided by adjacent side, it is 8. 15 by 8. Okay, here we can have another is with respect to angle C. Suppose if they ask, by giving these all values, if they ask what is sin C, then what are the values? Sin C. Yes, anybody? What is sin C? It is going to be sin C, it is opposite side to sin C is AB, adjacent side to angle C, it is nothing but BC. Okay, so sin C is nothing but opposite side length divided by the hypotenuse, so that is 8 centimeters by 17. And cos C, if you want, for finding cos C, you have to find the adjacent side length, that is nothing but BC for angle C, that is 15, and divided by the length of the hypotenuse, that is going to be 17. Now if you take the ratio of this tan C, we know you can directly calculate from the diagram, or you can take the ratio of sin C by cos C. Sin C is 8 by 17 divided by 15 by 17. Here we can cancel this 17 in both numerator and denominator. We get it as 8 by 15. This is tan C. Cot C is nothing but 15 by 8. Okay, and I am telling here cosecant C is nothing but 17 by 8. Okay, similarly secant C is nothing but 17 by 15. If you directly look at the diagram and want to find what is tan C, that is opposite side to angle C divided by the adjacent, that is 8 by 15. That is what we got here, 8 by 15. So from the diagram also we can calculate. Thank you for watching. Please subscribe and share. Thank you very much.